Okay, we're in section 25, the notes doing the examples. I want to claim though, the examples for the most part start pretty simple and we'll go through that pretty quickly. So like 1, 2, 3 is pretty simple, 4 is simple. Let's see, 5, more difficult. I want to tell you why it's more difficult. It's using your skill set in algebra to get derivatives and it's not easy, all right? So we'll go through it. And the point I want to go through is there is a point to it. And we give these to make points, all right? The point we're trying to make over here is that at some point in your careers, you have to start to realize that things get really tough and nasty, and you want to use tools to get better at it. I do recommend you read through my notes. If you have any comments or concerns about what's being stated in notes, please bring them to my attention. But pretty much things are written down for you, all right? And we'll go through that one by one, all right? So I'm going to say the first 4 problems are going to be simple. The 5th problem can be a killer for a lot of students. All right, let me go to the whiteboard. I got to do a share for you. As I go through this over here, I want to point out the reason we give you notes is we want you to look at them. All right, and study the notes that we're giving you. We're actually trying to, winnow down what's in your textbook into meaningful tidbits that you can use to move forward in your studies. All right, give me 1 second. And certainly I'm going to go, rapidly through the first few problems. And the first problem here, I'm going to say it looks really simple to me. They want the points of inflection. So the first thing I would do, and again, we'll look at the key later, is I'd write the derivatives down. And what's that going to be? Well, that's going to be 4x cubed over 12, which is going to be x cubed over 3. Minus that's going to be 2x over 2, which is just going to be x plus 3/5. All right, let me check that. Let's see, that's 3. Yeah, I see that. Yep, I think I did okay there. F double prime, which would be, let's see, that would be x squared now, right? Minus 1. What would I do? Since points of inflection, I'm going to factor this, x plus 1, x minus 1. I put my number line down. By the way, the domain of this thing is all real numbers. And what do I get over here? Plus or minus 1. Sign analysis, number between minus 1 and 1 would be 0. Plug it in, you'd get, let's see, you get a positive, negative number. What does that mean? Concave down. I'll take a number after 1 like 2. And again, we're plugging it into the second derivative. That's what they're asking about points of inflection, by the way. Like 2, what do you get? A positive number, means concave up. Number below minus 1, like minus 2, and you would get a positive number as well. Where'd you learn about sign analysis? In Math 119. So now what I did is I found my points of inflection. And my points of inflection occur at x equals minus 1. The actual point is going to be minus 1, f of minus 1. Point of inflection is a point in the curve of f where the concavity changes. The other point of inflection occurs at 1. And what's that point going to be? 1 f of 1. All right, concave up. It's concave up. Whoops, sorry about that. On the interval from minus infinity up to minus 1. And it's also concave up from 1 to infinity. Concave down on the interval between minus 1 and 1. All right, let's look at our answer key. And certainly I'm looking at it. This would be my work if this is an exam question. There's not much else I can say about that. They did have points of inflection. I did put that down, wrote the domain down, put the points of inflection down, and I put some work down, all right? So I want to point out, we typed this stuff up for a reason, by the way, that I do see the points of inflection are listed over here, and I do see the concavity is being listed over there. So I'll make sure I put that down. Yep. And then we did this over here as well. Let's go to number 2. Number 1 is relatively simple question. If that was an exam question, I would feel pretty confident that I answered that correctly. And I'll put down number 2 down. It's more difficult because it depends on your ability to understand pre-calculus at the trigonometric level. So I'll write down f of prime of theta. That's going to be 7. Now the next guy, I got to get the derivative right over here. That's going to be 14. It's the reason because the sign, the derivative of cosine sine minus sine. So cosine theta, sine theta. Well, I think that's pretty reasonable. And I'm going to write this down instead, though. I realize that I don't want a product. So I'm going to write this as 7 minus 7 times 2 cosine theta sine theta. And now I'm going to do one of my identities I know about. And that's sine of 2 theta. Let me get my second derivative. And again, I'm hoping it's easy for you to do this now. And let's take a look. That's going to be what? That's going to be minus 14 cosine of 2 theta. Now, this is an exam question. You're going to get credit for writing that down. Now, what do you need to do? I need to analyze the second derivative on the interval between 0 and 2 pi. Okay, so I got to figure out what the cosine curve is 0. And this was something you studied in Math 120 at Essex County College. So 2 theta, the first place where the cosine curve takes on a 0 is at pi over 2. And it keeps repeating itself every 2 pi k, with the understanding that k is an integer. So that means theta is going to be pi over 4 plus pi k. I divide both sides by 2. What's theta? You write a little differently for you. 4 pi plus 4 pi k. There's a reason for that, by the way. It makes it easier for you to do the arithmetic. 2 theta. Where's the other place the cosine curve takes on a 0? Is at 3 pi over 2 plus 2 pi k. What do you get over here? Theta equals 3 pi over 4 plus pi k, or a little differently, 3 pi plus 4 pi k over 4. These are things you learned in Math 120 at Essex. Again, for the students that need to go back and review that, you can come by my office and I'll point out where that review material is, including videos and problem sets that you can practice that material if you desire to do so. All right, so what I'm going to do over here is I'm going to write down the angles now. And I know it's difficult, but I have to do it. And before I do that, though, I want to point out that I want to get that 2 pi in terms of pi over 4, and that would be 8 pi over 4. And the reason I do that, it's easy for me to count. So this first angle up here, I'll put down theta. What's theta going to be? Well, the first one would be pi over 4. And the next one would be what? I'd take k to be 1 now, 5 pi over 4. Now, if you took k to be 2, you're beyond the range, by the way. Let's do this one over here. And let's see what you get over here. You get 3 pi over 4. And the next one would be 7 pi over 4. And I'm gonna put them down in order, right? And again, I'm not saying I'm great with spacing these things, but that doesn't matter to me. Let's see, 5 pi over 4, right? And then 7 pi over 4. It's tough, though. I realize that. Now, by the way, my native language is not in radian, it's in degrees. So what I want to do is just talk about the degree measures over here for you. This is 45 degrees. Well, 3 pi over 4 would be 3 times 45, which is 135 degrees, right? And then 5 pi would be 5 times 45 is going to be 225, right? And what do you get over here? That would be 7 times 45, which is 315 degrees. All right. So I want to tell you what test points I'm going to pick. And I'm going to speak in degrees, by the way. I'm going to say 30 degrees would be a good test point here. Between 45 and 135 degrees, I would say 90 degrees for me. It's easy. Between 135 and 225, say 180. Between 225 and 315, I would say 270. I'm picking numbers that I find easy to deal with. And between 270 and, I'm sorry, between 315 and 360, which is 2 pi, I'm going to pick don't know, 330. I'm going to plug it in here. And it should be easy. This will be negative. We'll plug in the 90. That's 2 times 180. This will be positive. Again, you would need to evaluate trig function. At 180, this would be negative. At 270, I would get positive. Again, I'm plugging into that thing I have circled. At 330, it would be negative. So what I find? I found a bunch of points of inflection. I'm going to put them down for you. So the points of inflection occur at pi over 4. That's where the concavity changes. 3 pi over 4. That's where the concavity changes. 5 pi over 4. That's where the concavity changes. And 7 pi over 4. That's where the concavity changes. What are those points? If you want to list them, it's pi over 4, f of pi over 4, 3 pi over 4, f of 3 pi over 4, 5 pi over 4, and f of 5 pi over 4. And the last one is going to be 7 pi over 4, f of 7 pi over 4. All right, let's look at the key and see if I've answered their question. And what's their question is, find the points of inflection. I found those. And I want to point out it's written down this way. You know what? Did I use? Oh, yeah, I used that. I'm sorry. So I got pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. By the way, I also drew a picture for you. And I want to point out the picture is somewhat helpful. And you may not agree with that, by the way, but these are the points of inflection in the picture. And those points as specified would be at pi over 4, 3 pi over 4. This is pi over 4. This is 3 pi over 4. This is 5 pi over 4. And that's 7 pi over 4. Now look at my analysis. What I say? I said concave down. I clearly see that. Concave up, concave down. And I'm looking at my number line to do that. Concave up, concave down. Things look pretty good. All right. That's number 2. Let's go to number 3. Number 3 is another problem for me. And the problem, to be honest with you, is derivatives. It really is my problem. So let me write this down for you. Let's write an f prime. We have an answer key, and we give you an answer key because we want you to look at the answer key. So f prime, I have to square that. By the way, the domain is all real numbers. So I have to square the bottom. Bring the bottom to the top. Times the derivative of the top minus the top times the derivative of the bottom, which is 2x. Now, this is where a lot of students say, I'm not going to simplify. I'll just take the next derivative. Not a good idea. You really should always be looking to simplify. This is manageable. I'll tell you why it's manageable. I'm going to get 1 minus x squared if I simplify the top. Let me just make sure that's true. 1 plus x squared minus 2x squared. Yeah, looks good. Okay, now what do you do? Well, maybe you're going to forget, but you're going to get the second derivative now. And again, it's going to be a lot of work. So 1, not beyond our skill set, though. And again, we have a key to look at. We'll look at that. Oh boy, let's see what I got. Minus the top times the derivative of the bottom, which is 2, 1 plus x squared to the first power times 2x. Wow, this looks really tough. All right, let's put this down, all right? And let me just simplify a little bit. I'm going to put down minus 2x, 1 plus x squared squared. And then I'm going to put down, I don't know, minus 4x. Be really careful here. 1 plus x squared. And let me see if I'm doing that. 4x, 1 plus x squared, and 1 minus x squared, right? Well, what I notice, I'm going to reduce it now by dividing top and bottom by 1 plus x squared. So you get 1 plus x squared cubed you would get minus 2x times 1 plus x squared. Then you'd get minus 4x. Make sure I didn't make any mistakes here. Let's see, minus 4x and 1 minus x squared. All right, I do some more work. I know it's a lot of work. We're encouraging work though. I'm going to factor out a minus 2x, by the way. And what do I get? I get 1 plus x squared plus 2, 1 minus x squared. I don't know. Maybe this is going to work out nicely. Who knows? Minus 2x, 1 plus x squared cubed. And what are you going to get there? You're going to get 3. X squared minus 2x squared is minus x squared. So I'm just going to, maybe hope I got the right answer. But when right answer, I'm just saying I'm heading for that derivative. Did I get it? And you know what? I see it here, but they wrote it a little bit differently, but it's the same thing. I do see 1 plus x squared cubed on top, on bottom, and I see the 2x. They just simply commuted the minus sign into that. It would give you x squared plus minus 3 in that case. So I feel good about that. So next thing I'm going to do is put this. This is the second derivative, by the way. I'm going to put down my zeros now. And one curves at 0, and the other one curves at plus or minus root 3. Relatively simple so far. I'm really helpful. So I'm going to do my test points. And what are the test points going to be? Let's write this down for you. And I'm going to put a test point over here, like, what's after root 3? I don't know, maybe like 5. Bottom's always positive. This would be negative, and this would be negative. So what do I get? I get positive. All right, let me go between 0 and root 3. Take a good test point, like 1. And what do you get? You get negative. What does this mean? Concave up, concave down. All right, let's do minus 1 now. What are you going to get? Positive. Concave up. Let's go below minus root 3, like minus 5. Plug it in, you can get negative. Where'd you learn this? In Math 119, sign analysis. So I got my points of inflection. I'll write this down for you. It occurs at minus root 3, it occurs at 0, and occurs at root 3. What are those points? Fairly simple. Minus root 3, f of minus root 3. We'll look at the key later. The next one's going to be 0, f of 0. And last but not least, you're going to get root 3, f of root 3. If someone said, where's it concave up? I could write that down pretty quickly. It's concave up on the interval between minus root 3 and 0. And it's concave up on the interval from root 3 off to infinity. Where's it concave down? Whoops. Well, minus infinity is an interval up to minus root 3. And the other place it's concave down is between 0 and root 3. All right, what was your question? I don't know. I got to read it to you. It says we got the derivative, points of inflection. We got this over here. Again, when I'm doing this over here, I want to point out, I'd like to look at the picture because they gave it to me. They say there's a point of inflection at 0, and then at like the root of 3 somewhere over here about. Put this over here, and again, looking at my analysis, concave down, concave up, concave down, concave up. All right. Again, I did that in my analysis, and I'm hoping you realize that's over here. Again, concave down, concave up. Concave down, concave up. As we said, points of inflection. Again, this is 0. This is root 3. This is minus root 3. Again, thankful for the picture. It helps me. So I'm going to say number 4 is probably the last simple question. I want to point out these are simple. These would be gifts on exams. And I'm going to go through it with you. All right. So again, it's about that inflection point. All right. So let's take a note of number 4. And I'll write this down for you. F of x, I want to do f prime. And I'm going to say, well, maybe the first function, x squared, times the derivative of the second function, which is 1 over x, plus the first function. I'm sorry, made a mistake. The derivative of the first function, which is 2x, times the second function, which is the natural log of x. Simplify, what do you get? X plus 2x ln x. I would factor out x. It makes it easier for me. It may not make it easier for you, but it does for me. I would now write the second derivative down. So let's see the first function, which is x, times the derivative of the second function, which can be 2 over x, plus the first function, I'm sorry, the derivative of the first function, which is 1, times the second function, which is 1 plus 2 ln x. It pays to simplify things if you can. This would be what? 2 plus 1 plus 2 ln x. That's going to be 2 ln x plus 3. That's second derivative. I'm going to look at this over here. Wow, miracle. We got that right. What am I going to do now? Number line. Before you go forward, I want to point out the domain starts at 0, goes off to infinity. And I want to find out, does that second derivative, it's never undefined in the interval, is it ever equal to 0? Well, it's equal to 0 when the natural log of x is going to be equal to what? Minus 3 over 2, which means x is going to be equal to e to the minus 3 over 2. Okay. Now, some people say I need a calculator to do that. Not really. I'm just going to pick really safe, easy test points here. So I'm going to say E. That's a nice, easy one over here. And a nice, easy test point over here would be E, I don't know, minus 2. All right. You're going to plug it in, or you plug it in here. It's either going to be positive or negative now. If I plug in E, what do I get? 2 plus 3, which is 5. That's positive. What does that mean? Concave up. Now, if you plug in e to the minus 2, what would you get? You get minus 4, because the natural log of e to the minus 2 is minus 2. So you get minus 4 plus 3, which is negative. So I know I got a point of inflection. Let's write this down. My point of inflection occurs when x is equal to e to the minus 3 halves. And then the value is going to be f of e to the minus 3 halves. All right, concave up from e to the minus 3 halves out to infinity, and concave, that's up. Concave down from 0 to e to the minus 3 halves. All right, let's look at the k. Really looking at it, I'm reading it. We recommend you read it as well. And over here, I'll just go to the next page. I'm reading that. It looks pretty good. My work supports that. Answer they're giving me there. Say points of inflection curves at e to the minus 3 halves. We got that right. Look over here. And it's not, the easiest thing to look at, but I do see this concavity thing. It's concave down here, and then it changes to concave up here, right? What is this point over here? It's e to the minus 3 halves, f of e to the minus 3 halves. All right, pretty simple. All right, here comes a tough one. But I want to point out, if you're on the exam and you're struggling, get off the question. So number 5, I'm going to tell you, it's tough, but not the first few questions. Like the first question is x-intercept. Right? That's got to be easy, like a pre-calculus question. How do you get x-intercept? Well, you set the function equal to 0. If you did that, what would you get? This would be the work. We're doing A. None. Why is that? There's no way that could be 0. It's 2 plus some positive number, right? Well, I should say non-negative number. And 2 plus a non-negative number, this is non-negative number. There's no way that could ever be equal to 0 for a real number system. So the answer is none, and that answer is listed for you. How about y-intercept? That's also going to be easy. These are confidence builders. How to get a y-intercept? All you have to do is set the x equal to 0. What do you get? 2 plus 0. And what does that give me? It gives me 2. So what's that going to be? X is 0, y is 2. This is right over there. Horizontal asymptotes. Also easy. So C is easy. Someone says, I wonder when it's going to get difficult. The derivatives. Let's write this down. The function's 2 plus x squared over x4 plus 1. Super easy limit. That's 2. Let's go to minus infinity. That's going to be, let's see, what would that be? That's 2 plus x squared, x4 plus 1. It's still 2. So what I know, horizontal asymptote. It's an easy question. Y equals 2. Let's look at the picture, by the way. Hey, I'm seeing the y equals 2. I'm going to say this point's pretty much known to me now. This point over here is 0, 2. It looks like it's touching the asymptote over there. And, I'm going to say there's 2 other points that might interest me. They'd be the maximums. The 0, 2 looks like a global minimum. I'm going to say it looks like there's some points of inflection on this curve over here. Who knows what they're going to ask next, though? Let's take a look at that. I got this one, did the work for you. The next one says find the derivative. This is going to be work. But I want to see if I get that first derivative thing. So I'm going to write the function down. And the function's this over here. And I don't think this is going to be like so tough you can't do it. But there's a point to it. So I want to see if I get that first derivative. Well, I want to remind you what the function is. The function's this. I can get a derivative. Derivative, the first term is 0. Second term, I can do it. I gotta be careful here. I gotta match that derivative they've given me. The derivative top is 2x minus the top times the derivative of the bottom, which is 4x cubed. Right, that doesn't look too bad. Now, so what we're going to do now, I'm actually going to divide through by the highest degree of the term x4 plus, I should say factor x4 plus 1 that's shared by all of them. Well, none of them. I'm not going to do that. I was hoping. What do you get over here? 2x5 plus 2x minus 4x5. Well, let me keep writing this down. Again, we'll look at their answer in a second. What do you get over there? You would get minus 2x5 plus 2x. I would probably factor out a minus 2x now. And what do you get over there? x4 minus 1 over x4 plus 1 squared. I just want to see if I got it. And I'm looking at the K. Bingo, success. I got it. What am I going to do now? Analysis, because I want the extrema. Minus 1, 0, and 1. They're the zeros in the problem. Do some sign analysis. You pick some test points. I got to point out it's super simple to do that. I want to recommend you learn that if you have not learned that from 119 yet. Sign analysis is something you're going to be using a lot. So I'm going to say like minus a half here, maybe 2, and maybe minus 2. Let's plug them in one at a time. Let's plug in 2 first. What do you get? Negative. Bottom's always positive, by the way. I'm not worried about that. Negative times a positive, negative. What does that mean? Decreasing. Let's do minus 2. What do you get? Positive times a positive. It's a positive, which means it's increasing. Let's do a half. What do you get? Negative. And then you get negative, positive. What does that mean? Increasing. Let's do minus a half. You get positive times a negative, which is a negative, decreasing. What do I now know? Let's write this down for you. I know I got 2 maximums. I'm going to say local max at the point minus 1, f of minus 1, and the other local max is going to be at 1, f of 1. By the way, I want to point out, I want to go to the prior page. I want to point out, I knew that they're right there. But in addition to that, having that little graph over there, pre-calc sketch, whatever, it's really not a pre-calc sketch. I kind of know they're global. So I'm going to put that down. These are global. They're global maximums. And where's the minimum? Again, I'm looking at these pictures over here, max, max, min. The min occurred at 0, f of 0. And this is, looking back over the picture, I want to point out what I mean by that. I'm seeing this is not only a local minimum, but it's a global minimum. So it's local and it's also global. Where's it increasing? As expected, here and here. Where's it decreasing? There and there. Let me point out, this stuff's all written down for you. We do recommend, on my chicken scratch over here, I do chicken scratch where I type the notes up for you, but I do type the notes up for you as well. All right. Increasing, what do you get over there? Minus infinity to -1, and I got my mouse over there. And where else is it increasing? Between 0 and 1. Looks pretty good. Where's it decreasing? Between -1 and 0. I got that. And it's decreasing. I'm looking at my picture. Let's see, 1 to infinity. Good. Got that. Okay. So I'm going to say right now, and let me just put a line over here. This is where the line in the sand is drawn. For most people, they should be able to do all this work here quite easily. It's what comes after this. It's tough. So the first thing over here is this is going to be really difficult for students to do. I find it difficult too. But what we have to do is we got to get the second derivative. To do that, though, I have to be really, really, really careful. Let me write this down. So let me write down what f prime of x is. It's going to be x4 plus 1 squared. But I go too fast with that, just copying. And I got to be really careful. It's going to be 2x, I'm multiplying it out for a reason, by the way, minus 2x 5. All right, so 2x, because minus 2x times minus 2x, and 2x times x4 is going to be, 2x5, but it's subtracting it, right? So here comes my trouble. My trouble is getting the second derivative. So let's write this down. F double prime of x there's a point to this, by the way. x4 plus 1. I got to square that, right? So it's fourth power. Then I'm going to bring the bottom to the top and leave it alone. I don't think I went too fast there. Times the derivative of the top, which is going to be 2 minus 10x4 minus the top I think I did it right there, right? Times the derivative of the bottom. 2 x4 plus 1 to the first power times 4x cubed. This is crazy. By the way, if that was it, that's not that crazy. I could write that down. Is it right? I have no idea. I really don't. So what I'm going to do now is I'm going to try to cancel things off. And I want to point out what I'm looking at over here. I'm looking at these things. Right. I hope you realize that they all have the same factor in common, which is x4 plus 1. So I'm going to do a reduction. And I'm going to cancel one of the factors. Okay? And this would be x4 plus 1. And over here, I'll just write this down with a minus sign. And that's going to be, well, that would just be 1, right? All right, let me write the other guys in now. I'm going to put this guy down now. I'm going to write down as 2 times 1 minus 5x4. Let's factor a 2 out from that. A lot of work. All right, I'm going to put this guy down now. That's going to be 2x times x, not x, no, I'm sorry. 1 minus x4. So that would give you, let me just make sure, 2x minus 2x5. Looks pretty good. I'm going to put 2 down now. And I'm going to put 4x cubed down now. All right. This is a nightmare. So this is when it's going to stop. I don't know. I got to keep going. 2x4 plus 1 minus 5x4 minus, by the way, I just wrote this down. So all I've done, I moved things around a little tiny bit, but nothing substantial at this point. I'm going to take these things here and pull them together. And what would you get? I mean, certainly subtraction problem. You definitely get x4, right? And 2 times 4 is 8. And 8 times 2 is 16, right? Let's see, 2x, 4x, 16x, 16x4, and then 1 minus x4. What's on bottom? x4 plus 1 cubed. x4 plus 1 cubed. I'm going to put this down in little tiny pieces. This is going to be, let's multiply it out. What do you get? You know what? I can do that without the parentheses there. I can actually do it. I'm going to erase around. I want to point out I'm doing this over here because I think I can handle it. Minus 16x4 plus 16x8. All right. This needs to be done too. Let me write that down. 2, that would be x4. I'm using just probably multiplication, minus 5x8 plus 1 minus 5x4. Boy, this is trouble. There's a point to it though. I bet I made a mistake somewhere. Who knows? Let's see what happens. 2x4 minus 10x8 plus 2 minus 10x4 minus 16x4 plus 16x8. I'm starting to see sunlight. I'm not saying I'm right though. Let's take a look what we got here. Well, I'm seeing terms now, right? I'm seeing this term and this term. If I add those two terms together, what would I get? 6x8. By the way, let me forget the guy in the bottom. I always do that sometimes. All right, let's go to the next thing. Let's see. That's minus 26, right? Minus 24. Plus 2. Let's keep going. 2, 3x8 minus 12x4 plus 1 over x4 plus 1 cubed. I'm hoping I got the right answer. Let's take a look. 2, 3x. Miracle. Absolute miracle. There's a point to this, though. Here comes my next problem. And it's a problem. I got to get the zeros for this thing over here. Let's go to the next page. And I want to point out in the next page, well, let me go back and I'll grab the derivative, by the way. And I really should emphasize what we're doing over here. And again, there's a point to this. So really what I'm doing is I'm trying to find out when the zeros of this thing over here. Certainly as I'm doing this over here, I'll talk through it, but it's a nightmare. There's no doubt about it. But there's a point to it. There's a point to every nightmare. I'm looking at this thing, and what I'm gonna do is, I'm looking at this thing, and the bottom is never gonna be 0, and the bottom is always positive. The top could be 0 though. I'll put this over here. So the only time it could be 0 is if 3x8 minus 12x4 plus 1 is equal to 0. But I got to be answered, that's an 8th degree polynomial, math 119. You learned that this thing had 8 solutions to it. And I'm hoping that we can find the real ones. And the way we'd probably do this in math 119 is we probably say u is equal x4. And then what we get 3u squared minus 12u plus 1 equals 0. It's not factorable. When I say not factorable, I use my fingers. But I can use quadratic formula. What would I get? U, let's see, twice the a in bottom, right? So that's going to be 6. We'll look at the key later, by the way. Opposite of b, 12, plus or minus. Boy, it's going to be a lot of work. What do you get there? B squared, which is 144, minus 4 times a times c. I got to keep working on it. Sorry about that. I got to keep working on it. Hope I didn't make a mistake, by the way. We'll look at a key, though. That's what we have a key for. 144 minus 12, we'll put this on the side, is going to be 132, right? I can divide it by 2. What do you get? 66. So this is, why do you do that? I want to make it simpler for me. 2 times 66 is 132. And 2 times 33. So what do I know? This is 2 root 33 now. I'm going to reduce it. U equals 6 plus or minus the root of 33 over, I'm dividing by 2, right? 3. All right. I hope you realize that I didn't want u. I wanted what? I wanted x. What's u? It's x4. All right. The nightmare's not over yet. And the other one, let me write this down for you. All right, now what do I do? Well, kind of back in Math 100 land, I can write this down. Plus or minus the 4th root. There's a point to this, by the way. We'll get there. And again, for the students that read, the point can be read a lot quicker than it can be discussed. Well, by the way, this is clearly a positive number. I want to point out 6 minus root 33 is definitely a positive number too. So it's going to, there's going to be a real solution over here. We're getting 4 of them, by the way. All right, the nightmare's not over. I kid you not. Let's look, see if we got those answers, by the way. Look back over here. And I think I have that right over there. Let me make sure that's 6 root 33. Yep, we got it. We got those. Here comes my problem. Right, you think this is bad. This is my problem. Which I'm going to cut to the chase soon. What's the most negative number there? It's going to be minus the 4th root of 6 plus root 33 over 3. What's the most positive number there? It would be the 4th root of 6 plus root 33 over 3. Now, the other numbers can be over here. I'll put them down for you. So it's going to be minus the 4th root of 6 minus root 33 over 3, and minus the 4th root of 6 minus root 33 over 3. And then you do the analysis on it. I want to point out, you could cheat your way through the analysis by looking at the picture. And this is concavity, right? So what I mean by that is over here, it's up, down, up. You get the idea? Up, down, up, down. So it starts up, right? Okay. Someone says, could you really show that's true? No, without just mouthing off about it? You could do it. But here's the deal. I got to be honest with you. Let me go back to this. This is where most people draw the line. Even getting there, they have a tough time getting that. Then after that, getting to these things over here. This is really tough, but we did it. But I want to point over here is that I really want to point out that, I could write down all my points of inflections now, where it's concave up, concave down, all kind of stuff. It's all typed up for you though. I'm going to claim over here, it may be a good idea to read what I said over here. And I'll just paraphrase what I'm saying. Tools are important, all right? Most people, when they watch someone use a tool, they're in awe of what they can do with that tool. What tool are we talking about? Computer algebra system. So I'm going to say up to and including, let me go back to that, letter F. I can do that by hand, but at some point, you're going to start to use a tool. My recommendation is you should learn how to use a tool, how to get derivatives, all right? So I would claim over there, please read through that. Tools, there's a book, it's 2001: A Space Odyssey, about how people looking around in awe at people using tools. Tools are really going to be important for your moving forward. And I can't say enough about the computer algebra system. What computer algebra system am I hawking? The tool I'm hawking is Sage. However, don't feel it's the only tool available to you. For example, you watch 2001: A Space Odyssey. The initial tool they're suggesting that humans or pre-humans came in contact with was the use of a rock. Right, very primitive tool, by the way, but it's very useful. I've used rocks before as tools as well. It's super primitive, by the way. Rocks are not bad tools. You can do a lot with a rock, all right? You can do a lot with Sage too. I am recommending that you use Sage in some of these problems over here, particularly when they get difficult. All right, I'm going to call it quits there. Again, if you have any concerns or questions, please come by during office hours, and I'll be more than happy to help you.